Hi everyone, this is Ms. Burko. I hope you've been having a great summer so far. But given that school is coming up pretty quickly here, I wanted to get these videos out to you. So for the summer work, we really focused on graphing piecewise functions because that's what we've kind of noticed over the past several years that students struggle with the most at the beginning of the year. So we want to do a couple quick reviews to hopefully make this a little easier once we get rolling during the school year. So to start off, you'll notice we just have a few problems with graphing inequalities, and you'll kind of see why we started here in a minute. So the first one says to graph the inequality, x is less than or equal to 3. So we know because we have this less than or equal to, for us that meant we had a closed circle here. And then we know all the numbers smaller than 3 are to the left, so we shaded to the left. So it looked like that. Now for number 2, x greater than negative 4, right? Now I don't have that equal to, so that means I'm going to have an open circle on the value of negative 4, and I know that the numbers bigger than negative 4 are to the right. Now one thing I kind of want to point out here again, because it'll be important later, is that notice we didn't start at negative 3, because we know that numbers like negative 3.1, negative 3.2, right, all those numbers are also bigger than negative 4. So we could get kind of infinitely close to negative 4, but we can't include it, and that's why we put the open circle. Now, for our compound inequalities like number 3, right, I want to know the numbers that are greater than negative 2 and less than or equal to 5. So here I'm going to have an open circle at negative 2. I'm going to be closed at 5, and I'm going to shade in between. Again, simple ideas that you've been doing probably since Algebra 1, but we wanted to just do a quick review. So now we're going to get into graphing piecewise functions. And again, because these can get fairly complex, we're going to start off by graphing them using tables. Now, before I even get into the table, one thing I like to do is kind of look at where that breaking point of my function is. And I know for this one it's at negative 2. So at negative 2, I'm going to switch from using this function to using my second function. So something that I find helps students, is just drawing in kind of a dotted line at x equals negative 2. I don't know if you can see that. But that kind of gives me a reference point. I know that at this dotted line, x equals negative 2, I should be switching the function that I'm using. So I'm going to make a table for my two functions, just an input-output table. The first one I'm going to do in purple here, so 3x plus 8. So I'm going to do a table with my inputs, my x values, and my outputs, so my function values. And again, I'm looking at x values that are less than negative 2. Now, like we did up here, even though I'm less than negative 2, right, I'm still going to include that negative 2 in my table. So here we had a negative 4. We just put an open circle around that. So I'm going to include negative 2 in my table. I'm just going to make myself a note that that's going to be an open circle there. So if I plug in negative 2 to this function, I get 3 times negative 2 plus 8, which is negative 6 plus 8, or 2. So I've got 1 point there now. Okay, now less than negative 2, I'm going to go ahead and do a negative 3. So I have 3 times a negative 3, I'm not going to write this all out, is a negative 9 plus 8 gives me a negative 1. And I'll do one more, a negative 4. So 3 times a negative 4 is a negative 12 plus 8 gives me a negative 4. So now I've got 3 points, and that'll help me draw out that piece. Hopefully we recognized by looking at this that we should have a line. So when we plot our points, if we don't have a line, that means we did something wrong. So let's see, I've got negative 2, 2, and again I said that was going to be an open circle, so I draw it open. I've got negative 3, negative 1, and then I've got negative 4, negative 4. And that's looking linear, so I'm happy about that. And so now we're just going to connect these dots here. Okay, and I've got my first piece of my piecewise function. So we're going to use the same idea here with the table, and now we're going to graph this x squared plus 4. And hopefully, since we've noticed that x squared, we should know that this is going to be a parabola. So again, I'm going to do my input-output table. Now, again, I'm going to start at -2, but this time, since it's greater than or equal to -2, we're going to have a closed circle here. So I'm just going to include that in my table. So again, now we're just substituting and evaluating. Here we have to be careful with our negatives because we're doing a -2. We're squaring that quantity and then adding 4. So a -2 squared is going to give me a +4 plus 4, which is going to give me 8. I can do a -1. So a -1 quantity squared is going to give me a 1 plus 4 is 5. I'll plug in 0. 0 squared plus 4 just gives me 4. If I plug in 1, I'm going to get 1 squared plus 4 is going to give me a 5. And then 2, we know these parallels are going to be symmetric. So if I do 2 squared is 4 plus 4 should give me a value of 8. And again, I'm going to go ahead and plot these points. So -2, 8 we said was closed because it's greater than or equal to. I've got -1, 5, 0, 4, 1, 5, and 2, 8. So I'm going to go ahead and connect those. Again, I know this should be a parabola. Makes sense to me because it was a x squared just shifted up 4. And there I've got my piecewise function. Now, what I shaded in at -2, we can go ahead and just get rid of that. That was just to remind me that that's where my function should kind of shift over from one to the next. Okay, so nice and easy using tables. So we're just going to try, I think, one more, and then you'll have the opportunity to kind of practice. Now, the only difference here is one, the notation, and then the other thing is that I actually have 3 pieces to this function. So as far as notation here, negative infinity to -1, is just the same as saying x is less than -1. And I know it's strictly less than because I have these open brackets here. Now, for this one, my boundaries are -1. Now, this is less than or equal to because I have a closed bracket. And then I have, I need my x, and then less than 2. And then for my last one, 2 to infinity is the same as x greater than 2. And again, because those are open, I'm going to have strictly greater than. So I know my breakpoints here are at -1. So again, I'm just going to kind of quickly dash this in at -1, and then my other breaking point is at 2. Again, that's just going to remind me that my functions should be changing when I hit those kind of vertical lines there. And we're going to do the same thing. We're just going to do a table for each piece again. So here, I'm going to have x and f of x. So this was less than -1. Again, I'm going to start at -1, but that's going to be open. If I plug in -1, I have 2 times the -1, which is -2. I could plug in -2, so 2 times the -2 is -4. Plug in a -3 would give me a -6. And again, we have a line for our first piece, so it'll be easy to tell that we did this right. So at -1, I have -2, so I'm going to draw an open circle there. -2, -4, and then -3, I have -6. Okay, and again, I'm just doing a quick check. This makes sense to me. I know I have a line with a positive slope. My rise is 2 over my run, which is 1, which gives me a slope of 2. So that makes sense. So I'll connect these. And we've got our first piece of the function. Our second one is going to have that parabola shape. Okay, and so I'll do my table here. Again, just going to do a basic input-output table. So here I'm going to start with -1. This one is actually going to be closed because I have that closed bracket there. So if I plug in -1, again, we're being careful with parentheses. I have 2 times the quantity of -1 squared. So that -1 quantity squared is going to be a positive, so this gives me a value of 2. Then I'll plug in 0. If I plug in 0, I get 0. If I plug in 1, I'm going to get 2. And then if I plug in 2, that's at the end of that interval, and I'm noticing here it's going to be open. I have 2 squared is 4 times 2 is going to give me 8. So I'm going to go ahead and graph that. -1, I have a positive 2, and we said that was going to be closed. 0, 0. My next one is 1, 2, and 2, 8 is going to be open. So sketch that in. There's my parabola. And then lastly, I have another linear piece with a negative slope. And this is going to start at 2, but again, that's going to be open there. So if I plug in 2, I have the opposite of 2 plus 3 gives me 1. And now I'm going x greater than 2. So I'll plug in 3. So the opposite of 3 plus 3 is 0. If I plug in 4, the opposite of 4 plus 3 is a -1. So I'm going to plot those points. So at 2, I have a value of 1, and that is open. 3, value of 0. 4 is -1. And then I can draw that in. And there's my piecewise function. So not everyone will need to use tables all the time, but I think this is a good way, if you do struggle a little bit with this concept, to kind of organize your work and make sure you have the appropriate pieces. So that's it for the first video. You have some practice with this, and there'll be one more video where we use the parent functions to talk about these piecewise graphs.